Welcome back to User Upload, where we take a hands-on approach to ethical hacking and security engineering through CTF challenges and real-world simulations. This machine focuses on the exploitation of a server-side template injection vulnerability identified in Handlebars, a template engine, and Node.JS. Server-side template injection is a vulnerability where the attacker injects malicious input into a template in order to execute commands on the server. Here we can see a decision tree depicting the identification of operations in order to test whether or not they are successfully executed when entered. If the payload we enter is successfully validated by the template engine, a more specific payload can be crafted to allow for a remote code execution. We will be utilizing some browser extensions and Burp Suite in order to help us with this exercise. Let's get started. Get started by launching Bike. We'll then get our IP address and we'll perform an Nmap scan. Before doing that, let's go ahead and take a look at the questions. Task 1, what TCP ports does Nmap identify as open? Task 2, what software is running the service listening on HTTP web port? Task 3, what is the name of the framework according to Wappalizer? We'll be checking out that browser extension as we move forward. Task 4, what is the name of the vulnerability we test for by submitting 7 multiplied by 7. Go ahead and take a look at that as well. For the Nmap scan, we're going to be using SVSC to detect the service version. We'll also be doing O for operating system, A for aggressive, T4 to speed it up, and we'll -P- to check any open ports on the system. Here we can see port 22 is open via SSH, 8.2.1. You can also see that port 80 is open for HTTP. We'll go ahead and launch a web browser and go to the IP address provided to us. This will be port 22 and 80 for task 1. You can see that port 80 is running Node.JS. That's the answer to task 2. Task 3, what is the name of the web framework according to Wappalizer? Let's go ahead and launch our web browser. We'll type in the IP provided, 10.129.55.12, and we are brought to this web page that's telling us it's under construction. It also shows us an email submit form. And we're able to use Wappalizer to find the browser extension running in Node.js. Here we're going to take advantage of the submit form here on the page, and we're going to enter some commands and see what's actually returned back to us, as well as some payloads to see if it's successfully validated in an attempt to identify the server-side template being used and if we can manipulate it or not. Here's a quick diagram again of the identification process. And once we identify that an SSTI vulnerability exists and which template is being used, we'll be able to gather more information about which payload we want to use. Here we'll enter the email address and turn off Foxy Proxy. Here we actually submit our email. You can see that we get returned back with a message. We will contact you at ponex@hackthebox.eu. Here we're going to test for the server-side template injection. We will grab a payload from, I believe it is Hacktricks, based on the identification. Here you can see the payload we're going to be using. And basically what's happening is we're going to be grabbing the package from Burp Suite, going to be encoding it with this payload here and sending it back to the web server in an attempt to get command execution. So the code here at the bottom saying this push returns required child process.exec, who am I? That's actually going to be a command that's executed. Here's the post, the HTTP packets that we've been able to gather from Burp Suite. What you need to do is open Burp Suite and configure Foxy Proxy. Send the request to Burp Suite, and here you can see the host, user agent, of course the language it's been provided to us in, what it's been encoded as, and at the bottom 14 you can see email is equal to percentage of 7B, and actions is equal to submit. This is what we're actually going to be taking a look at as well. That data is encoded, so we will have to send that over to the decoder. Here we've grabbed our payload from Hacktricks. I'm going to send this to the repeater. As you can see, we've grabbed the payload, successfully encoded it, and sent it back to the server. On the right, we can see our response. We do get an internal server error. The reference error is required is not defined. This is actually what we're looking for. We're going to be changing the parameter here. Answer to task 7, what kind of encoding did we just use for the payload? That would be URL encoding. As we can see on the right as well, the error that we got that's produced from sending the payload is require is not defined. We need to define this parameter. What variable is the name of the top level scope in Node.JS. On the same page, we can actually see the top level scope by looking at the path directory. Look at the notes, pretty much exactly what I just said. The URL is encoded, sent to the repeater, and we get an object response, meaning the property is indeed available. Then we attempt to call or require and load a module. We can load the child process module as it is available on the default .Node.JS installation. Can be used to execute system commands. This .push return process .main module .require. We will load the child process module and attempt to run the system commands. Followed up by exec sync whoami. An attempt to, of course, ask the system who we are as a form of code execution. We're going to need to encode the payload again before we send it over, so let's do that now. Encode as URL. Paste it, send back. Here we can see the response we've gotten as well as the note. So taking a look a little bit closer here on the right side where it says we will contact you at 2 object function native code. At the bottom of that it says root. Okay, that's who we are now in the system. So what that's doing is it's telling us we have successfully executed commands onto the machine. And this machine is indeed vulnerable to an SSTI. We can use these low-level privileges to escalate and to enumerate some more information about users and data. And we'll go ahead and do that as we answer the rest of the questions. So we'll change who am I, and we're going to list all of the files. Command will use ls/root. We'll have to encode the payload again before sending it. Encode it as URL, copy it, go back to the repeater, paste it in the repeater, send it back. Here we can see a couple files that have been listed for us. We have backend flag.txt and snap. We'll go back to Burp Suite, we'll cat the file flag.txt, and the file is going to provide us with the flag. So cat/root/flag.txt, and in the response we're provided with 6b, 25, 8d, 72, 6d, blah blah blah. My head's in the way. That's the root flag. So go ahead and copy that, paste it in, and we have just pwned bike on Hack the Box.